Before we move into taking a look at the rest of this unit, we need to go back and review some special relationships you should have already learned in middle school. The first, which I want to talk to you about, is the concept of perpendicular. When we talk about perpendicular, we're talking about two lines, rays, or segments that are called perpendicular because they create a 90-degree angle. Now, you'll see this in a picture by seeing this little bitty square in the corner of the angle. When you see that, that is the marking for perpendicular. When you see that marking, we can say that the two segments, rays, or lines are perpendicular and write the notation using this upside down T. If you take a look right here, there's an upside down T that represents perpendicular. So we would read this as the ray AB is perpendicular to the ray AC. From that, we would know that we have a right angle. We would know that it is 90 degrees. Another term that you should have learned in middle school is the term bisect. Bisect breaks an object into two congruent parts. When you have an angle bisector, it's going to break the angle into two congruent angles. So here I have an angle MNP. If I have a ray or a line that goes through the angle to create two congruent pieces, and that's what those little arcs mean, it means those are congruent, then we know that ray or that line is an angle bisector. So if I know that NR is an angle bisector for the angle MNP, we can say that the angle MNR is congruent to the angle RNP. That is the definition of angle bisector. The segment bisector is very similar. When we have a segment bisector, it breaks the segment into two congruent segments. Segment bisectors always pass through the midpoint. So if I take a look at this segment ST, if I look at that segment ST and I know that U is the midpoint, then I know that it's breaking the segment into two pieces that are the same length. If I were to put any kind of line, ray, segment so that it goes through the U, then that is creating a segment bisector. So U is the midpoint for the segment ST. That makes the segment SU congruent to the segment UT. And L is the segment bisector. It passes through the midpoint and creates the congruent segments SU and UT. Another concept that you should know but may have never actually seen the official wording of it is the concept of reflexive. When we look at reflexive, we're talking about the idea that an object is always congruent to itself. We do this or use this anytime we have some kind of shared side or shared angle within a figure. So for instance, if I take a look at this figure over here on the left, there are two triangles in the figure, the triangle ACE and the triangle BCD. They have a common angle. That common angle is the angle C. So we can say that the angle C is congruent to the angle C by reflexive. In this figure, we also have two triangles. We have the triangle FGH and JGH. These angles, or these triangles, have a shared side. That common side is the segment GH. So we can say that GH is congruent to GH by reflexive. So that's the concept of reflexive. Now I also want to remind you that we've already earlier in our lessons learned about other special angles that have relationships of congruency, like vertical angles. Remember, when we have vertical angles are congruent. Vertical angles occur when you have two lines that make either an X or a cross, but they go completely over each other. The vertical angles are always the angles that are opposite of each other when this occurs. So the angle 1 would be congruent to the angle 3, and the angle 2 would be congruent to the angle 4. So you need to make certain you remember the rule about vertical angles as well before we get into the rest of this unit. We also learned about the angles that are created when we have parallel lines. When we have parallel lines, there are certain angles that are congruent. Now in this image, you're going to notice that we have right here a note that tells you these markings are telling you that the lines are parallel. That's what those shaded in triangles that are actually on the lines mean. It means that those lines are parallel. If we look at those parallel lines, if we take a look at those parallel lines are crossed by a transversal. So let's take a look at where those parallel lines are. Let's take a look at where the transversal is. The parallel lines are here and here. The transversal that is crossing the parallel lines is here. Now that transversal crossing those parallel lines is creating 8 different angles. The congruent relationships that happen in these angles we talked about earlier. The first of these congruencies are the corresponding angles. Remember that the corresponding angles are the angles that are in the exact same position. They're just at the opposite intersection point. So like for instance, if I take a look at angle 1, angle 1 is on the top left of the intersection. Right here's my intersection point. I go to the top left, there's my angle 1. If I go to the other intersection point and I go to the top left, I am at angle 8. Those are corresponding angles. So angle 1 and angle 8 would be congruent. We could do the same thing for angle 2. Angle 2 is in the top right at this intersection. That matches angle 5. Angle 3. Angle 3 is in the bottom left at the top intersection. That would be here. It's going to match angle 7 in the bottom intersection. And angle 4 is in the bottom right at the top intersection. That would match angle 6 in the bottom intersection. So this is what we mean when we talk about corresponding angles. We have to make sure we remember all of these corresponding or all these parallel angle relationships when we move into the rest of the unit. We'll get rid of those markings and we'll take a look at alternate interior. Remember alternate interior angles. Alternate interior angles are also congruent when we have parallel lines. The alternate interior angles are the ones that are between the parallel lines, but on opposite sides of the transversal. So if I take a look at my parallel lines are the 2 yellow ones. If I were to shade in between, the interior are the 3, 4, 8, and 5. But the ones that are on alternate sides of my blue transversal are the pairs that I'm looking for. So I'm looking at angle 3, I'm looking at angle 5. Those would be alternate interior angles. Now, if you take a look at those, one thing I like to tell my students is that they can do a shortcut. Alternate interior angles almost always create a Z or a backward Z, an in or an upside down in. They tend to create that zigzag effect. So if you can find that zigzag effect when you have parallel lines, you're looking at alternate interior angles that are congruent. My other zigzag happens with angle 4 and angle 8. These are the alternate interior angles that are congruent. The other special angles that we have when we have parallel lines are the alternate exterior angles. Alternate exterior angles are also congruent. Now this time we're dealing with the word exterior. That means we're looking for angles on the outside of the parallel lines. So we're not going to be looking inside. We're going to be taking a look at outside. So from our top parallel line, we'd be going out. From our bottom parallel line, we would be going out. We're not going to be dealing with the inside angles. So our exterior angles are 1, 2, 7, and 6. Alternate still is referring to being on different sides of the transversal. My transversal is blue, so that means I'm looking at angle 1 and angle 6. Those are on opposite sides of the transversal and on the outside pieces of the parallels. Then there's angle 2 and angle 7. So this has just been a real quick review of some terms that you should know from middle school and from earlier lessons that we've done, that you are going to need to have very, very much in the forefront of your brain as we go on with the rest of this unit. And I hope that you will have found this helpful.